Start recording. Great. Okay. So continuing on our discussion of best practices, I had stopped during our last class in discussion of something that was called continuous integration. So we had briefly looked at the accountable positions. I had noted a set of them that are required here. And those include the project manager, the risk officer, the development team, and testing team that are distinguished, each with a lead, someone responsible for continuous integration, the triage team being a part-time position. The continuous integration discussion was one we started last time, and I'm going to comment on in a more fulsome way. But keep in mind all that learning from last time's, because that will be required. Okay. We also talked about incremental deliverables. Okay. So for continuous integration, this is a practice which goes back to the 1980s, and it's really a reflection of advances in technology that allow for faster builds, faster construction of a software project based on source code. But in many ways, it also critically represents an advance on the process side, a realization of what's needed to keep projects from spiraling out of control due to an inability to integrate different components of the project. It started early on in daily builds. So back when I was working, for example, on the Excel project in the late 80s and early 90s on other projects there, what we were dealing with is daily builds. These are builds that would occur at night of the entire project code base, so that when you came in the morning, the new version of Excel was available for testing and for developers to start building and extending on. And there was a view at that time that this daily build was kind of a heartbeat or sync pulse of the system, because it would bring together the contributions of people across the entire team. So the idea is you might be working on your small bit of the code base, but every night you refresh your code base with all the contributions of others, so that each day you're building atop there, not merely alongside their contributions. Now, why would you do this? It seems like a lot of extra complexity to bring their code in while you're working on yours. But why would you do that? What's the motivation for it? Let's suppose you didn't do that. Suppose you were working on, a large component and you went a week without checking your code in. What might go wrong?
To break it.
Yeah. So when you check your code in, let's be more concrete. How could it break? Break is kind of a failure. What's the fault that leads to it? What's the driver for that? Conflicts. Yeah. So it could be that someone else has modified that same area of the code that you're modifying, right? If you're checking in once a day compared to once a week, does the chance of a conflict like that, a merge conflict, go down or up? Down by a lot, because you're modifying less code during the day, right? Okay. Forgive me if I'm being obvious, but sometimes these connections need to be made. By the same token, that's not the only type of failure. What other failure could occur beyond an honest merge conflict, a case where someone else is modifying that exact area of the code base, the same lines? What else could lead to a problem?
Two people writing the same thing.
Okay, yeah. So you could have two people writing de novo a given function, and you don't realize until both are done. Needless duplicated work, right? Both of you have created this thing. And one of by definition, there's been one of you who's essentially wasted their time. One of them will be adopted. Well, back there.
The person who wrote that giant book becomes sick, and then
Yeah, okay, so it sits unchecked in, okay, so that could be the case, or some vulnerabilities. And so something might go for a long time without being contributed, rather than being contributed along the way, yeah.
Kind of going with the idea that it's better to find the conflicts and fail now rather than later, because if you
That's
build
right.
something assuming that it's going to be one way and you continue working on other things
Yep.
with those base assumptions, whereas there was a conflict with those base assumptions.
Good, yeah, so look, if your assumptions are off, you want to know it sooner, and the sooner you check it in so that others can see it and tell you, wait a minute, this is off base, the better, right? So that's true, but there's an extremely important missing piece to what's been said. And in my mind, it's the singularly most common one. These software systems, like complex systems, they're made of pieces, but it's really the interconnections between the pieces that define the main functionality. They're not merely the bits of code in isolation, it's how they use each other. So if we have component A, and it uses B, C, and D, which are other components in the application. Maybe these are functions, it calls off to them. Maybe these are classes, right? Maybe these are interfaces, which are more abstract, and they support a number of classes through polymorphism. The point is, if A depends on these other things, it uses all these other things, then if you are counting on, there being a method in D with this certain name, these certain set of parameters, and someone working on D goes and extends that, changes it. It changes it from requiring one parameter to two, makes it more general. Or they go and they split a big awful function up into 5 pieces, or into 10 pieces, as those in 470 saw this morning. Suddenly A may not work directly in the original code, right? Now you've got to call, this function or that function. It has a different name. It has different numbers of parameters. So it's extremely common that your code depends on the code of others. And it depends on the code of others in a way that is sometimes fragile. That if that other code evolves, particularly if the interface with that code evolves, that your code may need to be modified. And the longer you go without checking in, the longer you go without refreshing your code with the newest updates for their code, the more you're going to be fooling yourself. You're driving blind. You're putting in place all these calls to things which are going to have to be changed later. If you're getting refreshes every day of their code base, then you're less likely to write a lot of code which has to change. Does that make sense? Yeah, I mean, this is extremely common. So someone off there is changing this, changing that, changing this aspect of the API, and the sooner you know about it, the better, because you're going to be, otherwise just blowing smoke. You're just going to be putting in place code which is broken from the get-go. And when would you discover that in times of old? Well, there was a phenomenon. It was known, actually had a name, I should note, well before the TV series. It was called the Big Bang problem. It was the problem of delayed integration. And the idea is you'd have different people on a project, all working on their pieces, and then maybe once a month they try to put them together and it just wouldn't fit. The pieces don't fit together because each of them is evolving and the other was coming on the old version and they've come a long way. And so you'd have the Big Bang problems of integration. People would try to put things together and it just wouldn't come together. And it might require weeks of work to get the pieces to work together after they were integrated. So the idea came to do this integration on a frequent basis, to do it on a nightly basis originally with daily builds. So when you were home at home sleeping or at home, enjoying yourself, the daily builds will be going on. By the next morning, you will have seen the results of the integration, etc. And along these lines, what would occur at night was a compilation and linking of the code in what's called a smoke test. Now, the smoke test has a very particular type of role in testing. Tests, by and large, are designed to help us find bugs, help us identify and and find bugs. The goal of the smoke test is a little bit different. The goal of the smoke test is to find out, is the system stable enough to be worth getting this update? Is it stable enough to be worth building a top of for testing? If you've checked things in and it hoses a large part of the functionality of the system, even if it compiles, if people can't use it enough to use common functions, they're going to have a hard time testing their components of the code. They're testing this item and the menu item, this other menu item, this new feature. And if they can't even start the system up properly or can't load in some basic data, they're going to be in a bad way. They're going to be in trouble. So the smoke test is designed to basically find out, is the system basically sane? Is it basically working? Okay. And that accompanies compilation to make sure A doesn't break at the compile stage because it's using parts of B, C, and D which are changed, which you'd have to update the code of A to make it work. So you're compiling and you're doing a smoke test, okay? And this daily build was a key part of regimens in a growing number of companies in the 80s and the 90s. Question? No. Fast forward 3 decades here, ladies and gentlemen. So I think the Excel team, actually, that I was on was one of the first in the world to adopt this process. And it was a revolution. It was a revolution in terms of productivity. But today, we look to what's called continuous integration. And if you go out there, looking for Apache Continuum, look for Jenkins and Hudson and Cruise Control, GitHub, all these different systems support this basic model of integration. And the idea takes daily builds, but takes it to another level. It's not merely daily. It's more or less continuous. What do I mean by continuous? Well, the term is an exaggeration in a mathematical sense. There's not a continuous flow in of code into the database, into the repository. What's going on is that whenever you finish a logical chunk of work, mark my words, you finish, meaning what? We talked about this earlier. What does finish really mean in this context? When is something ready to be shared with others?
Once it's tested.
Yeah, so it's more than written, more than just compiles. It should compile with other people's code. So that means refreshing your code frequently. Mark my words, with continuous integration, you should be refreshing your code, bringing in other people's changes, pulling their changes once a day, at the least. Maybe more frequently if there's a lot of development going on. And you should be testing your code against this. Before you check it in, you should be compiling it, testing it against the code that others have checked in. Perhaps doing some additional documentation, maybe getting it pure test checked, just run by. It should be specified. There should be specifications associated with it about its preconditions, post-conditions. And it should then be a candidate for check-in. And you check it in at that point. Okay. And when you check it in, what happens? I alluded to it last time. Does anyone remember? What happens when, at the time of check-in? What happens is a build. It's too expensive to do back in the 80s and 90s to do a full build whenever someone checked things in. Computer technology has evolved a lot. And so now builds are triggered by developer check-ins. So again, mark my words, when you finish a logical chunk of work. So this logical chunk of work, a couple changes that go together. They're kind of logically linked. You don't check it in if you're only halfway through and you're calling off to things which don't exist, or you change this, but you still need to change that to finish the thought. You're finishing that chunk of work, that sort of logical block of work, right? you're checking it in together. And that might be many times during a day. You're pushing stuff, you know? And here, other people can then get your updates. But before that, before they get their updates, the system needs to check that your update is a worthwhile update to get. And it's not going to break other people's updates. So what happens is the build. And the build includes compilation and a fill in the blank. 2 words. Smoke test. Includes the smoke test. Just like in older times, smoke tests are quite central. We still build, we do builds, we compile, and we perform a smoke test to make sure it's basically saying, can you even log into the system? You know, does it just do a seg fault as soon as you start it up? Does it, you know, have a problem with security so it can't even run? So this is kind of taking daily builds to their logical conclusion. It's not just daily, it's when you finish little chunks of work, and you are getting people's other code, hopefully many times a day, okay? Once a day at least. So why would you do this? Why would you do this? Well, taking, again, the principles of daily build further to avoid the big bang, you do it so that you can spot problems as soon as possible. It actually saves a lot of time if you can spot problems early. If you've built less with the mistaken assumption, if you've gotten the updated code, it means less throwaway work. You know, less work that has to be redone. You know sooner about an issue so you can head it off, right? So this can allow for spotting early issues early and heading them off, like in terms of, oh, there's been this change in D to the function. But more than that, ladies and gentlemen, that's the static side. The static side is recognizing, oh, it won't even compile, and you know it sooner, so you build less code that won't compile. You have to fix less things. You know, okay, they've updated that function. From now on, I've got to do the second argument to it. Does that make sense, first of all? But the second issue is dynamics of it, the runtime of it. Because if something is broken, if you check in your code to this new code base, and something is broken, the function is no, you know, this functionality is no longer working. Why does it help to do this frequently? For debugging, why does it help?
You can pinpoint when.
You can pinpoint because fewer things have changed. All this changed since your last check-in. You changed these 6 lines. That was a logical chunk of work. You changed these 6 lines, now it doesn't work. Worked this morning, those 6 lines different, now it doesn't work at all. Gives you a big clue as to where the issue is. If 100 lines, 500 lines have changed since the last time you tested it with other people's code, then you've got a lot more sifting to do to find the issue. So it can let you zero in on the cause of bugs. Does that make sense to people? You've got less, the delta is less from working to not working. You have fewer, the haystack is a lot smaller to look at. You've got 6 straws to look at instead of, you know, pile of 1,000, right? Okay, so continuous integration is a large issue, and it can help for quicker identification of problems, identify state of project via smoke test, can identify, can help facilitate coordination between people, right? There's less to throw away if there are problems, reduce likelihood of merge conflicts. You have a better sense of where you're at and how quickly you're proceeding. It reduces needs for status reports. It turns out that one of the best senses of where we're at with this project is to look at the outputs of these continuous integration about the builds that are occurring. How many builds have occurred in the past day? What have they involved, etc. So it gives you a sense of kind of the progress of the project. It can improve the team morale. You get these kind of intermediate products which are the state of the system with this little feature added, with that little feature added, with this bug fixed, etc. That provide really good understanding of the progress and can give a sense of forward momentum for the team. So it's a great thing in terms of building a sense of that we're going somewhere. Okay. Continuous integration is a big step forward in terms of software development processes, particularly compared to the big bangs that used to occur where people would go for a month before syncing up with others' code. That was a big problem. Continuous integration is a extremely widely used practice because it's so much more advantageous. Okay. Now, when we think about what's going on in the build, when we think about building as a result of check-ins, I'm actually deliberately, for the sake of relating it to something you're very familiar with, I'm hiding a lot of details. What else besides building takes place? What else besides compiling, I should say, might be included in a build that takes place every time you check in? What else besides compilation?
Formatting.
Yeah, so conceivably you could do some sort of canonicalization, the formatting, but more likely it'll check the format. So it'll do what's called a check style. In fact, there's a product called check style, all one word, that some teams have used to good effect. To basically make sure that the code checked in matches the expectations for the conventions of the team. So that's important. People heard me holding forth on it this morning, right? Conventions matter. They matter because they allow us to quickly work with large code bases. And check style will check the stylistic conventions associated with your code. That all methods have to start with some comments above them. You always use brackets inside of if statements, regardless of the number of lines, etc. Okay, check style. So checking the style things. What else would go on during a build besides compilation?
Probably run some unit tests.
Yeah, you run a bunch of unit tests, and sometimes unit tests are, if you look back 10 years, unit tests, the full set of unit tests for projects would often be unreasonable to build. Today we could do it. Could build for projects that aren't too large. We could run a whole swag of unit tests. Regression tests. What's a regression test? Anyone know? We'll come to it later in the semester in more detail, but yeah.
Testing over previous stuff.
Yeah, so make sure bugs haven't reappeared. Bugs that were fixed earlier. Or and also check that functionality that worked before hasn't broken. It was working before, now we want to make sure that it's still working, given the evolution. That's a lot more serious to a user if functionality that has worked breaks than if new functionality doesn't work. They're counting on the old functionality continuing to work. So, okay, regression tests, but what else besides, so tests are good, I like that a lot. What else besides tests? Well, sometimes what's needed for tests, for broader testing, not just unit tests, not just regression tests, but serious industrial strength testing, is you need to get this to the testing team. So you do what's called the deployment to the test servers. Maybe you've got a website, and you make sure that the updated JSP code compiles fine, struts code, whatever, and then you push it to the deployment servers. Push it over to those servers for, the test servers, the servers for the testing team. What else might be required? What do projects consist of, whether for testing or for deployment, other than code?
Documentation.
Documentation, yeah. So you auto-generate Java docs, for example. Good stuff. What else?
Data or other things that might be required.
Yeah, databases. You rebuild the database and repopulate it. Remember, repositories are not just for code and general purpose programming languages are familiar with. They include schemas, things like database designs that are checked into the repository as well. And ladies and gentlemen, one of the principles of good builds is that you build from scratch. You do a clean build. Why a clean build? Instead of just an incremental one. Just recompiles one thing, the things that have changed. Well, it turns out that incremental compilation is a great expedient, but sometimes it can miss things. Okay, sometimes there's things that can miss. Maybe using update dates to judge what needs to be recompiled, and sometimes those are off due to dating consistencies between machines or whatever. So you do a clean build, you wipe the database, you recreate the schema, you repopulate it with data with the updated, according to the updated schema. File the source code, integrate the appropriate database, maybe run tests, and you might also go and perform deployments or otherwise inspect the code with tools that will go over it and raise quality issues and go deploy the software. Okay? In an Ant script, for example, are you folks familiar with Apache Ant? Maven? Gradle? No? What did you use for your builds in 370? Mumble. Is that right? No, seriously, like, how did you build your code?
Just through the IDEs, I guess.
Oh, okay. Eclipse?
Yeah.
It's a big world out there. So IDEs are great, and that can be used. For a fair number of projects, we actually, and for professional software development projects, generally speaking, you're going to be using explicit build systems, whether it's SBT, the Scala build tool, or Maven, or Gradle, Ant, to encode the dependencies. IDEs hide a lot of things from you. And that's great when you're getting going sometimes, but I don't know if you folks are like me, but sometimes when I'm working in Eclipse or other IDEs, it's a little bit disconcerting because there's a lot of logic in there about what's being built sometimes, how these components are being integrated together, particularly if you have one component of your project that integrates with another one as different components. It's a little bit obscure what's going on. And so you break it out explicitly into files, like Ant files or what have you. Now, back in the day, I mean, you folks used in 2.14 and maybe in 3.32 make files? Glad to hear it. So we have a common language. Now, Ant is kind of make, but without a lot of make's classic issues. Make is it's a technology that's been around there for a long time. It has a lot of basic functionality that it provides, which is pretty good, but it can get really tricky to work with sometimes, and actually it can be very persnickety. It can be very truculent. It can be very. There are times where you can get really sick that make is being so obscure and sort of thrown off by slight things. It used to be that even I think if you had a tab versus spaces, it would throw it off in certain cases. I mean, it was horrible. It's horrible. So Ant was a new generation tool that came out probably about 10 years ago that dealt with that. And here you have explicit declarations of targets and so on. And per that era, it was encoding these dependencies not in text but in XML. So here, we might have a a project associated with it, and you define a number of things, including clean that cleans away the current status, does an SVN update to get most recent changes, compile the source, compile the tests, integrate with the database, run the tests, run inspections. And these are common things that might occur, in the context of a build, okay? So, the goal here is to kind of have it frequently getting check-ins. Someone should go no more than a day without getting the updates of other people, and they should be checking in things whenever they finish a logical chunk of work. Even if it's quite small, check it in and get it built. Build early, build often. Check it in early, know about the problems sooner rather than later. Problems fester. Problems metastasize. They spread in pernicious ways if you don't recognize them early. If you can find them early, you can head them off at the pass. So here, you're going to have some continuous integration. Then you may have rules on your team. I don't mandate this, but I think it's a good idea, governing bug fixing versus new development. So if you're a developer and there have been issues found with your code, often teams will mandate that you have to deal with those issues first, at least if they're of a certain severity, before you go and you add new code. You got to clean up after yourself before you can, do new things. And this is an issue with development mentality that often we'd like to add things in rather than dealing with that messy stuff, to debug it or what have you. Now, with this sort of fixing, there's often an attempt, and this used to be maybe once every few weeks that you would stabilize. So you'd go every day on an ongoing basis, fixing bugs that were identified by the daily builds, etc., fixing those, adding new things, and then once every so often, this might be every few weeks, you create a stable version that's ready for testing, and you hand it over to the testers. Not every daily build is always tested. You might choose to do so. I don't object to it. But sometimes you say, okay, it's not worth the test team having until these new features are added. And then they test that version for a while. And then a new version is rolled out for the test team. So it's not always the case that the test team gets it deployed to their servers immediately after its changes have been made for the first time. Okay, so let's see. Right, this is actually an important diagram here, and somehow I forgot my tablet today, so I'm having difficulty seeing the time. What time do you folks have? 2:18. Okay. So this is an important diagram, and I'm going to leave you with this thought. But the point is that when we're thinking about code and code bases, we're dealing with structured categories of code. So there may be code under current development. There's code that's unit tested, but not yet system tested. And it's sitting on that developer's desk. So they finish up some private code. They do some unit testing. It's ready to be merged. And then they've run, basically it's a check-in candidate. They've actually refreshed against other people's changes. They pulled the changes from other people, and such as with an SVN update. And here you're undergoing smoke testing. Okay? You should be doing smoke tests on your own environment if possible. And if it compiles and it basically runs the smoke test on yours, then you'd actually go check it in. Okay? And you check it in, and upon check-in, it's available on the server, but will undergo further testing there, just in case there's been race conditions with other people checking things in. Okay, those are some comments that I had. So maintaining a build is actually not a small issue. Maintaining the build maintaining this daily build or continuous integration is for many projects, a full-time job. For yours, it's not going to be truly full-time, but I would advise having some person designated as the build master and configuration master. Why does this require a lot of time? Why would maintaining a build require a lot of time? What could take up the time for that? Why could that require a fair bit of effort? What particular things might they be spending time on to maintain this build infrastructure? Yeah.
I'm guessing you have to figure out how the whole code, what it means and how it all works together.
Yeah, they're not too involved with that unless something goes wrong, because things are being checked in, and those things that are being checked in should be properly importing the components for these others or calling off to them. So unless something breaks, they shouldn't have to get too involved with, what depends on what. That's all part of what's being figured out by the compiler when you compile things. But if something breaks, then they have to get involved in that. And for deployment and so on, they may get involved. Yeah. Yeah.
As the project develops, the build might have to change as well.
You got it. That's a big issue. So that Ant script, when you build sources, the list of sources that have to be built, and the tools, this is some C code, this is some Java code, this is some Scala code. The specifics of that, this is in Python, maintaining that list of files and what their associated tools are, what pre-processing has to occur, that's pretty significant. Evolving the build scripts. Pretty significant. And don't think that problem goes away if you have an IDE. The point is you don't want everyone in your team to be separately maintaining their IDE. Okay, I got this new thing, I got to use this tool for that. No, you want someone taking responsibility for figuring out those pieces. And possibly that's what Tushita was referring to, that they've got to be thinking about what pieces and what technology and where it is and what folder it's in and all. That's certainly true, that they're concerned about where those pieces come from. What other things would evolve over time? Begins with an S, ends with a T. It has 2 words in it. Yeah, the smoke test. The smoke test has got to evolve as you add new features to the system.
It's 2:22.
It is end of class. Thank you very much. So you're going to be needing to evolve the smoke test, okay? So what do I expect from you? Continuous integration, you bet. Smoke test, yes. Build scripts that are automatic. No typing of the build commands yourself, yeah, on the server, okay? Thanks very much. Enjoy the career fair.